Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we are going to discuss a tutorial related to RRP manipulator and RRR manipulators. So the Jacobian tutorial, to be specific. For the RRP manipulator, we have already discussed the DH convention and the homogeneous transformation matrix in our earlier tutorial video. So here I will just quickly go through that part, and then we will go and discuss about the Jacobian more in detail. So let's start, inshallah. So Bismillahir Rahmanir Rahim. So this is a typical RRP manipulator. So in the base you have a revolute joint, and then here is another revolute joint on the shoulder, and then on the arm you have a prismatic joint, as can be seen here. So by convention we can put all the frames as follows. So this is our 0th frame, this is the first frame, and this is the second, and this is the final at the tooltip is the third frame. So now, as you know that for the case of convention, we have to make sure that the x2 should be perpendicular to both z1 and z2. So unless we shift this second frame and coincide with the first frame, this cannot be happened. So in that case, we have to shift our second frame, and then we have to put it back here. So once you do that, then we can come up with a DH table by following these rules. So this is the DH table for 0 to 1, 1 to 2, and 2 to 3. You can find out all the values of respective A, alpha, D, and theta parameters. Once you have this DH table, then we are ready to derive the homogeneous transformation matrix by using this formula. So this is our homogeneous transformation matrix for individual transformation. So A 0 to 1, we should put all the theta 1, alpha 1, and D1 values here. So then you get this transformation matrix. Then A1 2 is as follows, and A2 3 as follows. Once you have the three individual transformation matrix, then you multiply all these three to get the A03 transformation matrix as follows. So from this transformation matrix, we know that the x coordinate of the tooltip is defined by D2C1C2, y coordinate is D2S1C2, and z coordinate of the tooltip is D1 plus D2S2. So once you have this x, y, z, then we are ready to derive the Jacobian matrix for this particular problem. So let's do it. So we can say that here x equals to D2C1C2, D2C1C2. So J11 equals to del x by del theta 1, which is minus D2S1 minus D2S1 C2, and J12 is del x del theta 2, which is minus D2 C1S2, and J13 is del x by del D2, which is equals to C1 C2. Similarly, y equals to D2S1C2, D2S1C2, so del y by del theta 1, D2C1C2, del y by del theta 2, minus D2S1S2, minus d2 s1 s2 del y by del d2 s1 c2 s1 c2. And for the case of z, we have here d1 plus d2 s2, so del z by del theta 1 del z by del theta 1 equals to 0 del z by del theta 2 d2 c2 J32, this one J31, and then finally del z by del d2 equals to s2 J33. Oh, sorry, s2, which is equals to basically nothing but J33. So once you have these all the components of the J, then your JV matrix is J11, J12, J13, J21, J22, J23, J31, J32, J33. Okay. Now we have to find out the J omega. So we go to the next slide. So the rule for J omega, as you know, is rho 1 z0, rho 2 z1, and rho 3 z2. So rho 1 for our case is a revolute joint, so the value of rho 1 should be 1. Rho 2 is 1 as well because it's a revolute joint. Rho 3 equals to 0 because it's a prismatic joint. So Z0 can be found from A00 matrix, which is nothing but an identity matrix. So A00 base to base is nothing but an identity matrix. So you have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So as you know, the Z is the third column, first three elements. So this is the Z0. So your Z0 is 0, 0, 1. Similarly, Z1 should be found from A01 matrix. So from A01 matrix, if you see the previous slide, it is nothing. So your Z1 would be equals to S1 minus C1 and then 0. Similarly, Z2 is, we got it from A01. And Z2, though it is not needed because rho 3 equals to 0, but still, let's try to find it out. We should get it from A02 matrix. So once you multiply A01 to A12, then you'll get A02, and your result would be, for Z2 would be equals to C1, C2, S1, C2, and S2, which is A from A02 matrix. Third column, first three elements. So your total J matrix will therefore be as follows. J would be JV, J omega. So JV will have J11, J12, J13, J21, J22, J23, J31, J32, J33, and this first element is 0, 0, 1, and then S1 minus C1 0, and this is all 0 because it's a prismatic joint. So this is your final J matrix. Okay, I hope you have understood this problem. So this is the solution for the J matrix for RRP manipulator. Now let's try another one, which is a 3-link planar robot, which is similar to 2-link robot with slight differences. Let's draw the robot first. So the robot would look like something like this. So you have first link, then you have second link, and this is the third link. So this is one joint, and this is another joint. So this is the tooltip. Okay, so let's say this one is L1, this is L2, this is L3, link length, and this angle is theta 1, this angle theta 2, and this is theta 3. So this is pretty straightforward, similar to your 2-link planar robot. So in 2-link planar robot, also we know the DH table would look like something like this. So 0 to 1, 1 to 2, and 2 to 3. You will have basically here A, I, L1, L2, and L3. Because this is your 0th frame, this is your first frame, this is your second frame, this is your third frame. So, and then you will have alpha I would be all 0, all the z's are parallel. Similarly, theta di will be also all zeros, and theta I would be theta 1, theta 2, and theta 3. So once you have this DH, then you can straight away find out A01, 02, and 03. So A01 will be equals to, if you use the same previous homogeneous transformation matrix and we put the values, it would be very simple: C1 minus S1, 0, L1, C1, and then S1, C1, 0, L1, S1, 0, 0, 1, 0, and 0, 0, 0, 1. Similarly, a 1 to 2 is like this: C2 minus S2, S2, C2, 0, 0, 0, 0. This is 0, 0, 1, 0, 0, 1, 0. L2, C2, L2, S2, and 0, 1. Finally, your A23 is as follows, just simple, same thing: C3 minus S3, 0, L3, C3, S3, C3 0 L3 S3 0 0 1 0 0 0 0 1. Now if you multiply A02 equals to A01 times A12, and this will give you, if you multiply these two matrix, this one and this one, so you will end up getting this result, which is C12 minus S12 0 L1 C1. I am cramped to the space. Let me write down here L1 C1 plus L2 C12. Yeah, I think hold on, L2 C12, yes, L2 C12, and I think I have to erase because the space is not enough, so let me erase this one and rewrite it. C12 minus S12 0 L1 C1 plus L2 C12, and then here S12 C12 0 L1 S1 plus L2 S12, and then it will be 0 0 1 0 and then 0 0 0 1. So this is the A02, and finally your A03 is equals to A02 times A23, which will again give you the following result: C123 minus S123 0 L3 C123 plus L2 C12 plus L1 C1, and S123 C123 0 L3 S123 plus L2 S12 plus L1 S1, and then 0 0 1 0 0 0 0 1. So this is the final matrix. Okay, so our this is basically X, this is Y, this is Z. So now we can write, okay, so now we can write down this X, Y, Z coordinate. So let's write it down. Okay. X equals to L3 C123 plus L2 C12 plus L1 C1. So that means we have to do the J11. So J11 will be del X by del theta 1, which is given as minus L1 S1 minus L2 S12 minus L3 S123. So, and then J12 would be del x by del theta 2, which would be minus L2 S12 minus L3 S123, and J13 is del x by del theta 3, which is minus L3 S123. Okay, now next is y. L1 S1 plus L2 S12 plus L3 S123. So del y by del theta 1 would be equals to J21 is L1 C1 plus L1 C1, this one, L2 C12 plus L3 C123, and del y by del theta 2 is equals to L2 C12 plus L3 C123, and finally del y, which is equals to J22 del y by del theta 3 is equals to L3 C123 which is J23. Obviously, because there is no z, it is 0, z equals to 0, so J31 equals to J32 equals to J33 equals to 0. So this is for the z. So you have the JV matrix. For the case of so the JV matrix is done. So now J omega, you know it should be rho 1 Z0, rho 2 Z1, and rho 3 Z2. So rho 1, rho 2, rho 3 all are equals to 1. Rho 3 equals to 1. So Z0 is from A00 matrix, which is obviously 0, 0, 1. Z1 is from A01 matrix. So A01 matrix also we have already derived it, which is also 0, 0, 1. So Z1 is also 0, 0, 1, and Z2 should be equals to this is from A01. So Z2 should be from A02, which is equals to A02. So A02, okay, it is again it is again 0, 0, 1. So 0, 0, 1. So now we have the complete matrix of Jacobian as follows: J equals to J11, J12, J13, J21, J22, J23, and this is all 0, J31, 32, 33, and then you have here row 1 Z0, that means 0, 0, 1, and this one is also 0, 0, 1, and this is also 0, 0, 1. So this is the final version of our J matrix. So this portion, first three is JV, next three is J omega. So I hope you have understood this whole tutorial. If you have any questions or if you happen to find any mistakes, please let me know. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.